Hello. Today I'm going to teach you everything there is to know about u substitution. So let's say you're trying to find the antiderivative of something. And for the beginning, let's start off with something simple, like x cubed plus 3x squared plus 9 dx. And this equation, it's pretty simple. All it requires is the reverse power rule. So then it is 1/4 x to the 4th plus x cubed plus 9x. And then always remember the plus c at the end. So that was pretty simple. So let's try something a little more difficult. For instance, let's say if you wanted to find the integral of root 3x plus 9. How would you do that? And the answer to that is, back to the topic of the video, u subs. So basically, what a u sub is when you take this, or just any section of the equation, but in this example we are going to be using 3x plus 9, and then replacing it with u. But I think the best way to show how this works is with an example. So let's try solving this one. 3x plus 9 is equal to u. That's what our u is going to be equal to in this problem. So then we do that, and then, well, look, isn't that much nicer? So why don't we just go ahead and solve it right now? And the answer is because we can't. Because we can't find the antiderivative of something, because we can't integrate it because of the dx and the u, they don't really match. You can't integrate that because of the different variables. So what you need to do is you need to convert the dx over to du. And what you may be asking is, how do you do that? Alright, so let's go back over here to this. So what you want to do is take the derivative of that, which is the derivative of this side is just 3, because that, and then this is du over dx, because you're finding the change in u relative to the change in x. So if you want to solve for dx, you can just multiply both sides by dx and then divide both sides by 3, and then you get dx equals du over 3. So that means that you should be able to plug that into the original equation, and you should get 1/3 du. And now that should be solvable because it's u and it's also in terms of u. So then what you would get is, since it's u to the 1/2, I just like putting it like that before I integrate it. It just makes it look nicer because I know what I'm doing. So then you add 1 to the exponent, and then you divide it, so then it's 2 over 3, and then you multiply it by that, so then it's 2 over 9, actually, and then plus c, and we're done, right? Wrong, because this answer is in terms of u. However, we started off with an equation that was in terms of x. So what we need to do in the final step of our u substitution is plug the 3x plus 9 back into the original equation. So what we do is just 2 over 9, and then 3x plus 9 to 3 over 2 plus c. And then that actually is our final answer, right there. And so if we ever wanted to check our work, then all we have to do is just find the derivative of that and see if that equals the original equation. So let's do that to make sure I'm not lying to you. Alright, so the derivative dy dx of 2 over 9 3x, that's an x, trust me, plus 9 3 over 2 plus c. The derivative of that is going to equal, first you need to do this here, right? Because it's on the left, and we just do things in that order, because why not? And so we take that down, and we divide it, and we subtract 1, so then we have, divide, the 3's cancel out, so then it's just 1 over 3, and then we do the chain rule, so then we have to find the derivative of that, but since we already know that's 3, we multiply that times 3 again. That cancels it out completely, so then we just get 3x plus 9 to the 1/2, and then the plus c, since it's a constant, it just cancels out too. So then there we have it, our original answer. That's all there is to know about u substitutions. Goodbye.